can use Bluetooth with your iPad. So what I might do, I might just jump into some ideas. So these are some projects that or we as project officers have, you know, used across Australia, where we've implemented the microbit as part of learning with kids in classrooms. So I'll start talking about this first one. So this one I actually did a few weeks ago with the stage 1 class, and we linked weather. The topic was weather, and we were looking at how, you know, we measure weather, what sort of sensors people use. We also linked it to statistics and data. And so with these year 1 girls, we actually made a microbit thermometer or temperature sensor. It was really easy for the girls actually to do, because it's 3 lines of code essentially. So it was a good way to introduce the concept of algorithms and sequencing with the girls, and also applying code for a context. So we used Makecode, and we worked through the process together of making the temperature sensor. We also encouraged the girls to do a bit of a testing process where they would measure the temperatures of different spaces around the school using either both the microbit and a normal thermometer, and comparing the readings, and we'd have conversations as to why were they possibly different, why was temperature different in different locations. We were then able to map that data against, we created like a tally graph and a bar graph with the girls. So it's again bringing in that maths, those maths outcomes and those maths IDs. And the girls were able to talk about variances in temperature. I know, Meridith, you tried this with your school and you found there was an extra feature that you found. Do you want to share that?
Yeah, so when we found the thermometer wasn't very accurate, so we actually calibrated the thermometer by working out what the actual temperature was using a traditional thermometer, and then just using the maths blocks, you can put whatever the temperature is minus, so it said it was 30 degrees when it was actually 26 degrees. So we just put the math block, we just put temperature setting minus 4 degrees, and it actually then displayed the correct result relative to where we were. We can talk about, we can put something in later about that, maybe how to do that.
And I think that's a really good way, even if using that as an extension, if you want to move into higher grades and talking about maths and how you would use different kind of equations and comparative sums and things like that. So that's quite a nice little project and a nice way to introduce microbits. Like I said, this was a year 1 class. And it linked really nicely to their topic, and we were able to then branch out into looking at radars and how they're used, and the classroom teacher was able to then integrate a lot of what we'd done with the microbits to the maths curriculum, and then doing some art and things like that. So it's just a nice little project that you can do with young kids to introduce them to using a microbit, introduce coding, and link nicely to their learning. Does anyone have any questions about that one before we move on? And these are just ideas. I mean, there are probably 100 ways you could integrate it differently, and with different stages and topics. These are just some of the ways that we've found have worked quite successfly with kids.
There's no questions, Helen.
Cool, I'll move on. I keep getting emails at the same time. Got to turn that off. All right, so with stage 2, another nice way to use the microbit is to create a soil tester. So this project's been done a lot online, and there's so many videos on doing it, but it is a fun way and a fun activity that you can do with kids. So I'm actually doing this with a year 3 group of girls right now. We're linking it to a topic around farming and gardening, and we're looking at different ways that we can use technology to help us be more efficient in gardening or farming or sustainable farming practices. So This one is, again, quite easy to do. There is a thing that you can buy through the Microbit, through the Kiptronic kit. It's like a soil tester they've already got. I've got one here somewhere, but you don't need it. Like I made it with nails. So as long as you have 2 long nails or any bits of silver, you can use that, and you just, you create the digital system using the alligator clips and the nails and the Microbit, and then you code your Microbit to measure the amount of moisture in the soil, and what it will do is will give you a numerical reading. So anything that's kind of dry is closer to around 250, whereas soil that has more moisture in it is closer to around 1,000. So again, that's quite a fun activity and quite easy to do. And when I did it with the girls, we were able to use the readings that we got from testing. They've been doing a gardening project, so we were testing the different things that they've been gardening, the moisture in the soil of the different things that they've been gardening, and we were able to get different values. And then what we did was we plotted that on a graph. So again, looking at bringing in some of your maths outcomes and then having that conversation around, well, in that case, what could we do? What sort of ways could we invent something that, would help us automatically water the plants that need more moisture, and just leave the ones that don't. So that again can, bring in conversations around sustainable practices, and I think quite topical at the moment with water restrictions around the corner. Again, the girls quite enjoyed the project. And Meridith, have you done this one?
I haven't done it with a class, but I have made it. It took me longer to find the nails than it did to make the code.
Yeah.
But it is a really good one for all age groups. I actually like using it as a maths inquiry. So rather than asking students, do plants die with when they don't have water, we can actually say, how much water do plants require to survive? And then incorporate your volume and measurement, and get students to have the same plant through the class, and everybody waters at a different amount, and record how much is watered each day. And that way you're actually looking into keeping things alive and sustainable, rather than will it die if I don't water the plant.
Awesome. Does anyone have any questions about that project or that idea? Maybe some suggestions about how you might want to use it differently in your context, or how you could apply it in a different way with a different group of kids.
And just so everyone knows, that red underlined Microbit soil moisture tester, that's a hyperlink to the actual project. So we've linked to the code on how to build these as well.
I'm just gonna. Were there any questions?
Chris has just said it'd be great to do it with wetting agent and without wetting agent, compare the differences. I thought that's good too.
That's pretty cool. Yeah, I like that.
But Martin's going to contribute.
Hello?
Hi, how are you, Martin? You got anything?
Hi, Martin.
Hold on a sec, I've got 2 things.
A lot of me.
Just unmute. He's just ducked out. Martin's a NACARA project officer, and he's done a lot of work on the moisture tester as well. So he just unmuted, so I thought he might have said something. But we'll move on until he comes back.
All right. And I've just managed to make it full screen. I had to move something. Oh, Martin?
Yeah, it's a great activity, a really good activity to do with kids, because one of the few times that they get to calibrate an instrument in science is this.
Yeah.
It's really good. And all the rest of the stuff is sort of black box. They're going to number out of it and believe the number. But what's really nice is to add to the code for that says, well, if we can make it do a smiley face or a tick or a cross or give us a number, we can also then turn on a pump instead of doing that. So you can make a fully automated watering system if you wish.
Yeah, definitely. Definitely. That's awesome. Thank you, Martin. Oh, there you are. Hello.
The unit of measurement is, it's actually just measuring resistivity of the soil. So how long it takes the message to pass from one nail to the other. So the nails have to be a specific distance apart in all of your experiments so you can compare the data. But if you actually read the Makecode project, it goes through the reasoning of how to do it. And then Martin's giving you some more information. Thanks, Martin. You're awesome. So, but the Makecode actually has a lot of the science of the resistivity of soil in that, if you read the text. Yeah. Yeah, we keep going though, otherwise we won't get through all the projects.
Okay, so I'll introduce another one here. Now this one, we've included some photos from our awesome ACT project officer, Tony, who's done this quite a bit with her tertiary students. This is a nice little activity that you could do with stage 2 or stage 1, particularly if you're looking around animals and animal adaptation. So I know that in the science syllabus, there's quite a few outcomes that look at animals and different ways that animals use their senses to survive in their environments, or how they adapt to survive in different environments. And you can actually make you know, your little micro pets or adaptations of these animals using your microbeats. So you know, one of the, you could, you know, give kids, you know, the idea of, you know, how would we change a particular animal to survive in an alien or futuristic environment. So what could we, what would it do, you know, what could it flash, what sort of lights would it do, what would its facial expression look like? So you can incorporate things that way. You can look at it using your 3DP outcome for defining a problem and following an algorithm to develop a solution. So you could create a game with your animal. You could discuss how the game would work and how you could code the microbeat to do different things to react to or be part of your game. So you could start by defining, you know, what would your game look like, what's your code going to, what's your micropet going to do. You could describe how the code's going to work and create a flow chart to show what will happen. You can then code the game blocks using import and output. Can you see that, by the way? Or is yep. Because on my screen it's very different. So you could create a flow chart to show what will happen, and then you could create the algorithm, so code the game, and then you could end by, you know, following the algorithm to action the game. So you know, the example that we've looked at here is, so if we've defined the problem, so how are we going to make our game work? So well, on button A, when I press it, it's going to show a happy face. Whereas on button B, my animal's going to be sad, so it's going to show a sad face. So then how could I vary that? Well, I could add something to happen when the input is shake. So it might be a ghost, or it might be a silly face. And, you know, that really comes down to creativity and, again, building kids up to modifying their codes. The other thing I like about this project is you can just use stuff that you find in the classroom. So they were the one, I'll just go back, in the picture it was just paper cups, pipe cleaners, googly eyes, which every primary school classroom has, you know, paddle pop sticks, buttons. So you don't have to really go out and, you know, invest in a lot of elaborate things, because it's just stuff that you've already got in your classroom. So you're planning, when you work this through with kids, you could actually get them to create a flow chart to show the planning of how their game's going to look like. So on button A, this is what's going to happen. On button B, it's going to display a sad face, whereas when it tilts, it's going to do this, or when it shakes, it's going to do that. So it's, again, a visual representation of that code or that algorithm. And then you then move kids on to making their code. And talking about the, you know, how the pink or the input works, what will happen with blue, which is the output, etc. Does anyone have any questions about that one?
No. So the idea with all of these projects is the big priority is getting students to plan their work before they actually code. And that's what, and all of those sequences that Helen's just gone through there actually address each of the points in the stage 2 outcome. And if you're Australian curriculum, you would need to be looking at your stage standards and your content descriptors as to what you're required to teach. But for New South Wales, previous, what was it, 2 slides before? Those you need to go through those with each project before you actually code.
Yeah.
It's really important that you ask students to think through their problem and put it into plain text, regardless of whether they know how to do it. You want them to represent it, and it's called pseudocode, and they're putting it in plain words, and then they get onto the fun part of building the blocks.
And kids find that they find they get to that aha moment with the coding in a quicker way if they go through this process. Like, that's what I've noticed when I've done it in classrooms with kids, that if you just kind of go, okay, now code it to do this, kids kind of freeze and they don't know what to do. Whereas if they've thought about it and planned it, and we've broken it down and sequenced it, they were able to then, you know, more easily apply the coding aspects. So it's a really nice way to build up those skills, particularly for us in New South Wales, because it's all very, very new for a lot of the kids that we're working with. You know, that using code and creating it and applying it in a context. So shall I move on?
Yep.
People are moving and
I'm just putting some links in. A few people are asking, you know, where to go. And
yeah, and we can share this presentation with you after, and we've also got some other resources that we can email out to you as well that will help. And of course, we can come out and visit your school if you like to, and do some stuff with your staff. So, okay, so this is a one that you could do with both stage 2 and 3, and it would vary based on how you would, I guess, the level of your kids and how you would teach it. So it's just the dice, so making a dice using the microbit. With your stage 2 kids, it would really be using the 2 or 3 lines of code to display a number, and it would be, you know, on button A, show random number from 1 to 6. But you could then modify it for your stage 3 to include the if function, or to modify it to, instead of showing a number, it's going to show an image. You could also modify it to include various different numbers or combinations of numbers. You could incorporate it in your maths. So, you know, the traditional chance maths lesson of roll your dice, or how many, roll it 10 times, what's your result, what's the number you're going to roll the most, what's the number you're going to roll the least. I've actually used this with year 3, and we looked at it as part of looking at digital and non-digital tools. So we compared a normal dice with the microbit dice, and we talked about, well, how are they different? How are they the same? How have they made the process of picking randomized numbers? How has the technology made it, you know, more efficient or easier? You know, how can we modify one and not the other? So it's an interesting conversation to actually have with kids, to get them to think about different digital and non-digital tools, and why we would use one over the other. I found that to be quite a fun activity with kids. Meredith, have you had any other experiences with the dice?
I've done the intermediate activity with year 5, and it took, Helen's asked how long it takes. It probably takes about, it doesn't take very long at all to do the coding. Yeah. The coding probably takes about, I don't know, for a whole class, 20 minutes.
Yeah.
But the time-consuming part is the planning. You want them to go through the process of thinking, how is this going to work? I've got this board there, and when I shake it, I want it to work. I want it to roll a random number from 1 to 6. Do you want to display a 1, which is the beginner version?
Yeah.
With the intermediate, you've got an if statement in there.
Why is that?
You're branching in your iteration. So you just need to allow time for the planning. So I'd say it still takes the good part of 45 minutes. If you then incorporate the download, you have to allow time if they have never downloaded to a flash drive before, or to a thumb drive before. That took year 5 on a Chromebook about 20 minutes to get everybody to be able to do that, because they didn't know there was a downloads folder on a Chromebook. So if you've never done that, that's a skill you need to allow for the first couple of times. But that's an ICT capability that students need to have. So it's a really important thing to teach.
And sometimes I've found when we've Bluetoothed our microbits to our iPads, that can take, depending on your iPads and your Wi-Fi and your kids and your Bluetooth and all that, it can take anywhere from 5 minutes to 20. And I also had a similar experience with the USB download. So a lot of the kids I worked with had never used a USB before and didn't actually know how to drag a file over from one area to another. So that was interesting. So again, that's your ICT capability and your consideration for when you're planning it. But yeah, the code itself, it's 3 lines of code, so it doesn't actually take long. It's about thinking about the process of what it is and how it works, and getting your kids to try and work out how to get to that point.
I think it's also good to not just see this as a microbit lesson, because if you just make a dice, that doesn't really have much meaning. But if you incorporate it or integrate it into a maths lesson on data and on probability, where you roll the dice 36 times and then you shake the microbit 36 times and plot the data, what number did you roll, and then share that together into a Google Sheet, and everybody's data is all in there. You can find totals for the whole class for the dice and totals for the microbit. It actually gives a lot more meaning to the word random. Is it truly random? And I think the risk we have with just teaching digital technologies is you miss where it's relevant and the real world application. Because that sort of, depending, if you're working with a maths class in secondary, you might be talking about the probability of gambling and what's the likelihood that you might win the poker machines, or you might win at cards, or you might win, and that might be something you talk about around Melbourne Cup time. What's the probability of that happening? And different age groups would have different levels of understanding, of course, but it's really important you put the digital technologies into real world.
Yeah, definitely.
Yeah.
And then branching off that is this great activity about gamification and working with text. So again, like Meridith said, you can't just teach the digital technologies in isolation. The best way to do it is to integrate it with something that you're doing in another area. And so this is a nice one that you could do with literacy, that you could do with maths again, looking at chance and probability, and that's creating the rock, paper, scissors game. So you can create rock, paper, scissors with your microbit, and it's using your shake blocks. So again, working through that process of planning, you're going to ask your kids to define the problem. So how would you expect the game to work? So this is how rock, paper, scissors works. Traditionally, how would we use the microbit to play this game? They could then plan and design what their code would look like. So they might do that by doing a flow chart. So on shake, it's going to randomly select a number from 1 to 3. Now, this is where it would get tricky, because you'd have to introduce this concept of variables. So you'd create the variable hand, and then if the 1 is chosen, it's going to display a rock. If 2 is chosen, it should display paper, and if 3 is chosen, it should display scissors. So it's your bringing in your if else, it's also bringing in your variables. So this is where you would probably target this to a kind of probably year 4, stage 3, so 5, 6 kind of class or grade, depending on your context. So your code would look something like this. So the red part would be your variable. The variable is hand. You've used the maths equation there. We've picked the random block from 1 to 3, and we've used the if else. So we would be expecting kids in stage 3 to start looking at coding in that way. What you could then do is you could then ask your kids, all right, well, I might want to modify this game more. How would I do that? Let's introduce a 4th option. So if the 4th option is bomb, how would you introduce bomb? How would you modify your code to go from randomly selecting from 1 to 3 to 1 to 4? How would you change your image? So it might look something like this. So you'd have to include another else if, and then it would be a conversation, or how would you do that? And how would you then change your number? And then how would you change your image? And then could we then add a 5th one if we wanted to? So it's building up sequentially those skills, Meridith.
Yeah, you said it all. That's really important with stage 3 in New South Wales, is the modify, and there is equivalence in the Australian curriculum, of course, as well, because we're based on the Australian curriculum. But once you get to years 5, 6, they have to be able to modify code. It doesn't say that they have to write it all themselves. They have to be able to plan it, they have to create it and modify it. And they're the key things. And these, the blocks of if else and also loops, forever loops and repeats, they're really important constructs to understand in preparation for stage 4. And if there's any secondary people here in stage 4, you're supposed to be teaching the text-based coding rather than visual blocks. And there's no reason why you can't teach some of these as a intro, and then say, well, we've made the dice, or we've made rock, paper, scissors. Now let's move on to doing exactly the same project in text-based coding, so that they can see the link between the blocks and the text. Because at the moment you're dealing with kids in secondary who have never potentially coded.
Yeah. And at the top of Makecode, there's a toggle bar where you can flip between the two views. So, you know, a good way to do that would be to, like Meridith said, to start with the visual, flip between, look at how the text code has, showed the visual, what you've done in the visual, and then you could be asking the kids, well, where can you see the show block, you know, the show instruction, or where can you see the random, pick the random number. So, you know, a good way to introduce that using the block coding. Does anyone have any questions about that project? Like I said, we will send everything out to you so you can
I'm posting
work through
this.
it.
Yeah,
awesome.
No, there's no questions.
Perfect.
I'm answering questions as they come up.
Oh, you're awesome. Thank you. All right, the coin flipper. So similar to the dice, again, it's coding a microbit to be a coin flipper. So you wouldn't teach this in isolation. It would be combined with a maths or science lesson. It would look at things like, you know, chance. What side are you going to flip the most? What side are you going to flip the least? Again, modifying your code for stage 3. So if I've got 2 options, what if I want to add a third? How would I do that? You can also use it as part of gamifying learning. If you want to, if your kids are creating a game and they want to look at a different way that they can have user input to control the game, this might be another nice activity that you could incorporate as part of that type of learning. Meridith, have you had much experience with the coin flipper yourself?
I haven't used the coin flipper yet, no.
Yeah. All right. Does anyone have any experience with the coin flipper activity? Okay. All right, we'll move on. All right, so this one is it's similar to the virtual pets or the micro pets that we talked about earlier, but again, linking them to literacy. So it says stage 2 here, but I would even look at this in stage 3 and look at, again, animal adaptations and how different animals might adapt to different surroundings or different environments. This would actually work really nicely with the Aquatica and Mechanica books. So looking at how you know, different types of animals and insects and things might change in time and over the future. So you could be creating your roboticized animals or insects and using different types of, creating different types of games and varying different types of games. So this one was the bird, the chirpy bird. Meridith, this one was...
yeah, this is Crashy Bird.
The Crashy Bird.
I love
Crashy Bird.
But as you can see, the code for this is much, much more complex. So there's if statements and while do statements. There's the dark green block is actually the gaming menu. So this one links into coordinate geometry because it's using the X and the Y axes for the grid of 25 lights. It is much more complex, but it is fun and you get out very quickly because it's actually very small, a very small screen, so that it's very easy to get out. But the other thing it introduces is arrays. So this is quite a complex game if you're actually teaching the theory of it. However, if you get them to plan it with their pseudocode and you get to talk through what are we going to have to do, what do we need, I think if you've got a really capable class or if you've got some capable students,
yeah,
this would actually be a really good extension, particularly I would say after students have been working through these projects for a couple of years.
A while, yeah.
Because a lot of these projects we've talked about tonight could easily be in stage 2, and then it could be the type of the calibre project we're looking at within the next couple of years, or with kids who are just really good at it and love it.
Yeah. Like I know a few kids that are just you know, naturally great at coding and looking for that extra challenge, and this would be a way to extend those kids, you know, because it's that level of complexity is there, and that level of challenge is there, and you know, again, we want to look at extending kids as well, as supporting kids. So this would be a nice activity that you could do with that, or with you know, a gaming, like I know we've got at my particular school, we have like a coding club and a gaming club and robotics club. So if you've got any of those kids, or I know some schools also have GATS classes or GATS clubs, so this would be a great way to a great activity for them to do in one of those clubs or those groups. The voting system. So this is quite a nice activity that you could link to stage 3 when they're learning about Australia as a nation, learning about the electoral process. So creating an electronic voting system using the microbit. I actually did this with the Year 6 class for that very reason. So they were learning about the electoral process around the time of the election. So it was an interesting conversation to have about traditional electoral processes and how we can digitize those, how some countries have moved to that already, what that might look like, and then we created the voting system. It uses the radio features of uses the radio features, and you know, you can see from the code down the bottom, it is quite easy for kids to code that. But again, in stage 3, you might ask them to modify that. And what would happen if I pressed AB? Would that be a different type of vote? What if I wanted to vote for more than 2 options, or I wanted to vote for 4? So you could then include your pins or your alligator clips at the bottom here. Again, the link there, so if you click on that, it takes you to the project in Makecode, so that can work through that. And you know, kids loved making this, and they loved using it as a way. So we used it as part of their elections for school captain and things like that. So that was quite fun for kids to use to use something they coded and created for a purpose within their school. Meredith, have you done this one?
I just wanted to say on this one that this is a really great way, to teach how devices transmit data.
Yes.
It's one of the things that teachers really struggle to understand, of how they can form networks and how it can transmit data. So you'd be looking at radio waves. One of the resources we've got a link to at the end has a video on how the radio function works. And it's really important that you do talk about how it transmits, because that is a theme that starts in Year 3 and continues right through into Year 8, and potentially into the new ICT stage 5 units which are being developed, or Year 9, 10 units and curriculum areas. So it's an important thing. Bluetooth is also another way that computers transmit data. So if you're using iPad with the app to the microbits, that's a really great way to demonstrate how data is transmitted. And Martin's just made a comment that it's a good idea to practice beforehand, and I definitely agree with that. Yeah. It's a very different process using the iPad, and if you are going to go that way, and it's your first time, it's probably best to have gone through it yourself and have everybody on iPads, or have everybody on laptops if you can.
Yeah.
Yeah,
definitely. And then feeding into that, the radio waves and the transmitting data is another activity that you could do in stage 3, which is creating a communication system using the radio feature of the microbit. So using those radio waves to send and receive messages. So the Makecode has 2 projects on here. One's called Marco Polo and one's called Smiley Buttons, but you can obviously modify it to be anything that you like. So I modified it to be, are you listening saying, yes, I am. It would link really nicely to if you're looking at things like Earth and space and information systems to really establish students' understanding of how computers transmit data and how networks are formed and work and work, you know, together to you know, create that system. And again, you know, when you're doing this one in the classroom, you know, kids find it lots of fun that they can, you know, create something and send little messages to one another. You can also do, there's a Morse code activity as well, but I think that might be you know, it might be tricky, but it would also be a nice way of introducing binary in stage 3 too, and using binary language to send and receive messages. Meridith, have you had much experience with this one?
I haven't used this one, but the binary is a good activity as well. It is a stage 3 task, or year 5, 6. I think in Australian curriculum, it's actually a 3-4. It's introduced in 3-4. I'm not sure.
Right, okay.
Celia or Martin might be able to confirm that. But binary is something that it is important for students to understand because it is how computers communicate. So I'm just also posting a link to the Morse code activity.
Code one.
Yeah, so everyone's got that link now as well.
Yeah. Awesome. Okay. Does anyone have any questions about that one before we quickly move on? Okay.
No, there's no questions.
Okay. All right. So reaction tester. So Meridith, I'll let you talk through this one because Meridith's done this one a few times, and she actually shared it with us in Adelaide recently. So Meridith.
Yep. So the reaction tester is a physical. It's a bit different because you use chords and you're using the bar across the bottom this time for it to communicate. And it's a little bit, I don't know if anyone's seen the Makey, but it sort of starts to behave like a Makey, where those foil parts there, actually when you touch them and you touch the ground, they transmit a message through your body. So the idea of this is a game. Everyone puts a finger on the middle foil pad. The two players put a finger on the foil pad in the middle, and then the player on the left touches the left pad and the player on the right touches the right pad. When it counts down and displays the square, go. And whoever touches first gets their score displayed, their time displayed. So there's links to milliseconds. There's links. This was actually this picture here was taken with the pre-service teachers of secondary. So we were using a Kictronic kit. So we had actually tied it to using breadboarding. You could make this more difficult again by transferring this code and looking into the JavaScript, using the JavaScript tab for secondary. This has got a lot of concepts in it. It's got variables and it's got multiple points on each, like multiple things happening at the same time. So there's lots of groups of code, which you can see based on the mirror on the picture there. There's lots of things happening all at once. And it would be a challenge, I think, even to give the kids that code and say, can you tell me in plain text what's happening, rather than can you build it? And that way, when you can introduce more complex code, but get them to tell you what's going to happen based on what they're looking at.
And that's just as important, isn't it, Meridith, that kids are able to read and understand code and what's going to happen rather than just being able to build.
Yeah. And Chris has just asked what's breadboarding. Breadboarding is sort of the next step in electronics. I'll just see if I can find the Kictronic Inventor Kit, which is what we were using.
Yeah, I've got
Have you got yours? Mine's not handy.
Yep. I do. Sorry. Keep talking.
Just see if I can copy a picture. I don't know if I can copy a picture into there. That's a link there to the Kictronic kit on the, has it come up? Nope, hasn't come up. Oh, there you go.
Holding stuff
so
up.
What you can see there is that you can see a whiteboard with lots of holes, and that is a breadboard. And it's the old-fashioned way of how people used to build electronic circuits, and you would use those to prototype. You would prototype your electronic circuit, and then once they've built it with the wires, once they've built it, then they put it, join it together, and you can then downsize it and make it smaller to put inside something. So I'm just posting a link now to the Kictronic first project. It would definitely not be something I would do in primary school. Primary school is definitely not the place for breadboarding. It's the cognitive load for breadboarding is much higher, unless you've got a really exceptional student. Then I would leave breadboarding for the specialists in secondary. I don't even know if, Martin, if you've got any experience with breadboarding with 7 and 8. Thanks, Martin's just posted a link to circuit.io. But it's a fun thing to do if you love it, but it's a difficult concept, a difficult thing. The pre-service teachers had a bit of difficulty getting their head around how it worked. And
unless your kids are functioning at a very high level and are able to do high-end or difficult coding, I wouldn't think about touching it in K-6. But then again, you do have those kids that are just, working at those levels. So
I think a talented child, if you gave them this project just in blocks and just got them to build it, I think that would be that would be
enough
for the majority of the kids. That would be a big extension. But anyway.
Yeah. Okay. I've got, you can't really see it, but that is the microbit soil tester, the soil sensor. So if you buy that, that's that one there. But you can just use the nails.
Yeah.
Yeah. I mean, I've got it, and I didn't open the bag.
I'll see if where'd you get it?
Little bit.
Okay.
Yeah. So I didn't open the bag. I just used the nails. So, yeah. There you go. Okay, the firmware. So this can be a little bit tricky, but you do need to do this probably once every few months, Meridith. Would you recommend once every few months?
Yeah. So this is actually a maintenance part of using your microbits. The reason you would need to do this is if you've copied down your project onto your microbit and you're getting an error, it will often give you an error number. And if you Google the error number, you'll find it may be because the firmware is out of date, which is like the operating system for the microbit. So how you can actually update the firmware is you simply plug in your microbit. You go up to the cog, down to the menu pair device, and when you go to pair device, this window will come up. And the idea of pairing a device is it makes it actually easier to download. It will download directly to your microbit. But this is also acts as a way to tell you what version firmware you currently have. So over on the left-hand side of that window on the top with the red circle, the version of firmware at the moment for this microbit was 0249. So there are places in the Makecode website where you can find out what the latest version is, but to do that easily, underneath that in the bottom left corner with that red circle is check your firmware version. Click that, it's a hyperlink, it will take you to the place where you follow the instructions, go through and work out it will give you all the steps on updating your firmware. That is the first thing I would do if I know my code is correct and the microbit isn't working. That's the first thing I would do.
Yep.
The difficulty for a classroom is you potentially have 10 to 20 microbits in a classroom if you've bought a class pack. So you're going to need some clever bunnies to help you update the firmware of all the microbits. It's not something that you would want to be managing with year 3 or year 4 students. I would get a group of kids with a particular interest in computers to come in at lunch in a lunchtime club or a lunchtime and show them how to do it and help you do it. Maybe if they're good enough, they may even be able to do it for you on a regular basis without your help. So there was also a question about, is Little Bird competitive? And Martin suggested Core. There's lots and lots of places you can go. Kictronic sells stuff. what it is, I have been told by one of those suppliers that it is a race to the bottom in profit, and you need to check every time you order who is the cheapest, because I find the prices change. So if you search microbit and go to the shopping tab, looking for that will bring up overseas suppliers as well, of course. But I usually do a search and go and check, bookmark all your main suppliers and go and check each time. So
sorry, that's what I do too. I look, and there's websites that are like shoppingcart.com and things like that. So if you go to one of those websites and you type whatever you're looking for, it'll bring up, you know, all the kind of retailers and what price it is at the different retailers, and do it that way. And some schools have preferred suppliers. That can be tricky, but you know, I guess if your school's purchasing, you're purchasing on behalf of your schools, you might need to check what that is. I know you might have to go through procurement if you're with the department. So because some organisations prefer that you use their preferred suppliers to purchase things. So
I think there's warranty problems if you don't use procurement in the public system, isn't there?
Yeah.
If you just go out and buy it yourself because it's cheaper, they won't help if there's a problem. Martin's just said that there's a new microbit coming in 2019. So that should be soon, Martin.
That's exciting.
Yeah, so don't buy from eBay because people might be dumping their old products. You also get cheap. You'll also get cheap Chinese stock as well. You want to be careful that you're not buying. If it's going to be really cheap, you want to make sure it's value for money. Nothing worse than shelling out your money and then finding it's not doing what you want. I mean, $25 for a microbit isn't that expensive.
It's pretty good.
So some USBs only do power and won't do data. That's correct, which is why I would suggest you always buy the Microbit Go pack, which comes with your microbit, your cord, your battery, and your batteries. The batteries do run down. I'm about to invest in some rechargeable batteries to see how they go in the microbit, just so I don't have to keep buying batteries because some of mine have started to go flat. So, but do be careful that if you buy the $20 microbit box, it is only a microbit. For the sake of $5 to $10, you can get the cord and the battery pack and the batteries, and saves you running around trying to get another purchase order approved for school.
Okay.
So it's now 8:21. Is there any questions that anybody has? We've got 8 minutes. I'll share the PowerPoint again. Do you want to go through to the next slide and talk about the resources that we're sharing?
Yeah. So we've put together a list of resources here, and we can email these out to you and the links as well. So the first one, the summary of projects. So we've actually summarized all of these projects and a few other ones, and we've actually linked them to outcomes in New South Wales curriculum documentation, not just science and technology, but maths and English and whatnot where appropriate, and then also linked it to some of the Australian curriculum outcomes where we could find the links. So if you're looking for more information or you want to see what the sister outcome is in the Australian curriculum, you can would be a good place to start. Code Clubbers is a fantastic blog that has lots and lots and lots and lots and lots of microbit ideas and all tried and tested in classrooms, as is Code Club AU. There's also a Facebook microbit group, which we've just discovered recently, which is really, really good. So you can, you know, talk to teachers from around Australia who are using microbits and look at some of the projects that they've done, and you can communicate with them and share ideas and resources that way. And MicroPython and Microbits playlist, again, another place where you can find lots of resources and project ideas. We've also included some of our Twitter feeds, because whatever we do in our teaching contexts or in our workshop contexts, we share on our Twitters. If you're not following us, do follow us, because we do have updates on other workshops that CSER are running around Australia. So, you know, if you want to attend a public workshop or have a workshop at your school, you can contact us through our Twitters, our Twitter feed. So TJ Faluzzi is our ACT officer, Tony. Helen Kardia, that's me. So I'm the Sydney project officer, and Meridith is the wonderful Meridith. And Microbit also have their own Twitter account too, which you can follow as well. And we've got a Facebook. CSER has a Facebook group that we run Facebook Live events of. And what we will do is we will upload tonight's recording onto that group. So if you want to re-watch any of it or share it with someone that wasn't able to attend, you can do it that way. Sorry, my voice is starting to go.
There was a couple of questions there. So
yep.
One question was, what are the to do students? So what should we get students to do besides basic skills like downloading? Melanie, I just need a little bit more information on that question, because I just misunderstood that first sentence.
In terms of ICT general capabilities? Or,
yeah, maybe.
Yeah.
So other than click and drag and flash,
renaming files,
things that they find tricky about the microbit.
Yeah.
I actually they don't really find them tricky. I think the hardest part is just getting their head around the coding concepts. Renaming files, they do struggle. If they download Untitled, they'll get Untitled 1, Untitled 2, Untitled 3. So making sure they give it a name before they save. Also, they might need to just get their head around giving them logical names, because everything saves to the browser of the user that is logged on. So if it's a shared computer and they're signed in through a Windows password. Some functions also, like pairing, don't work in Safari or Explorer. I have yet to find out if they work in Edge, but they don't work in Safari or Explorer. So you need to have Chrome if you want to do pairing. Pairing's really great, particularly if you're doing Python. But you just click, once it's paired, you just click download and it flashes straight to the microbit. So you bypass that problem of clicking and dragging over. I think in years 3 to 6, that's a really great skill to, once they've developed that skill, being able to click, and that ICT capability, they might then move on to pairing. I wouldn't be pairing unless there's a kid with a special needs who has a problem, a fine motor problem. I think it's important they know how to do that. There was a couple of other questions there.
Pairing can be tricky if they've never paired before, and it can take a little bit of time depending on your kids. And like, I know that like when we tried to do it for the first time, some of the year 3 kids took a while to get their heads around it and follow the steps and whatnot. So just, be mindful of that.
Alice said she's doing an early warning system. Do we need external motion sensors? You should find the microbit should be okay. We've been experimenting with the data collection of using the XYZ axis. It does work, and I've actually shared a little bit later on, a couple of comments down, a link to a natural disaster project where he's got a wind, earthquake and temperature. So there's so many projects. You just Google what you think you'd like to do, put the word microbit in the search, and lots of projects come up. The difficulty is what Chris was alluding to about text-based languages. So by default, the microbit project code, Makecode uses JavaScript, but there is a Python editor as well. He's asked which is the best. I don't think there is a best. It's just like saying French or Spanish. It all comes down to your personal preference. And there are some people who are religiously only use one. I personally think it's important for kids to be exposed to lots of different languages so they can see that some are easy and some are hard, and some are, they all have their own idiosyncrasies. But you wouldn't be teaching text-based coding in a primary school anyway. That's a stage 4, a year 7 and 8 outcome. And you would be focusing on the theory and the structure of code in a block environment in primary school, and then move into the text. Hopefully by then they'll understand iteration and branching. So branching is your if then else, and your iteration is your repeats. They need to understand all of those concepts before they go into text-based coding. Are there any groups for teachers with text-based coding languages? I've shared one a little bit further down, but that's an Arduino site that I know of. I'm in that group, but that's to do with Arduino. So if anyone has any text-based language groups that they're in, you could share them. Otherwise, join some of the technology groups on Facebook. There's lots and lots of technology teachers. And anything with Peter Thompson in it. He used to be an NSW inspector. He knows heaps. So I'd join one of those. The Facebook group for microbits is awesome. I would definitely recommend it for microbits. And yes, thanks Melanie for the shout out. Our CSER MOOC might have some. There's there's 2 secondary courses, so maybe there's people in there who might be able to talk about text-based coding as well. In our MOOCs. Our MOOC is now moved to WordPress. So what you do is you log into our course, and do you want to share a link to the course, Helen? So if you log in through our online course, we've got an online course which is free. You can claim for accreditation 21 hours of teacher identified hours in New South Wales, and everyone else gets 21 hours toward their professional elements. They're all mapped inside the course, and there's links to our WordPress. So if you're not in WordPress, you'll need to join. But it is a really great course. And I'm just looking through more questions. Is there any other questions? Now, the Make Create Facebook site, that's actually my Facebook page. So, and I just share heaps of stuff about uni, what we're doing with the university through that group. That's my portal. So feel free to join. Thanks, Martin, for, it is a great course, and I highly recommend it. Thanks, Celia. So, the site can't be reached. That's a bit.
Sorry. I'm juggling 3 windows. Sorry. That is the one.
So just try that. They'll try that next one. So so if it's really just about getting one yourself, having a play, and definitely going through the Makecode website. The Makecode website has got lots and lots of great project ideas. It's got lots of great information, and I'll just post a link to this there. Now,
it's really easy to use. The tutorials step you through like step-by-step visuals, and that's also a good way that you can introduce the microbit to kids as well, using the tutorials.
That very first link on that resource page, summary of project with New South Wales and AC links, mapping of the Makecode projects. Do you want to open that so we can just show them quickly?
Yeah.
Grok Learning does have some really great text-based languages if you're looking to connect.
That link wasn't working, so I've just got to get to it another way. Sorry. I'm just going to...
Here, I've put it in the comments.
Because I'm not in Google Slides anymore, you see.
This is a document that I've put together with the project, a link to the Makecode projects. It's got a description of the project. So up the top, there's just videos about basic things. There's a video on how to do the maintenance. It's got potential New South Wales links. We're currently working through the Australian curriculum links because Helen and I are both based in New South Wales. We can't just automatically put in the AC codes because we don't know which ones are exactly the same as ours. So we're working with them. We're working through filling those in, and then a suggested year sequence, and also the skills, what we recommend. But beginner, it doesn't matter how old somebody is. If they're a beginner, that would be something you might choose to start with for a beginner. Okay.
Hang on. Just trying to get everything back up. I'm just sharing my screen again because I managed to get it up. There it is. So can you all see that?
Yep.
So it's got the project. There's a link to the project. So if you just click on that, it would directly link to the project. We've gone through and linked it to our New South Wales outcomes. So the digital technologies outcomes, and then a curriculum area, whatever it might connect to. And then we're like Meridith said, we're in the process of linking it to where our New South Wales outcomes link to the Australian curriculum outcomes. So it's a work in progress, but it's I think a really good resource to go away and work through and work with. And please feel free to add to it or send us some information and we can add to it. You know, if you come across other projects that aren't on here that you think might be worthwhile including, just let us know. Okay.
And when you're using the document, also just be careful not to move it out of the current location. So up the top, if you want to go back to that screen, Helen.
Sure.
So when you're using your Google Drive, just up the top, there's a picture, a faded out picture of Drive with a plus sign on it, just across from the word and the name of the file. There's a star, then you just click on that, and then you can add it to your Drive, and you can add it to any location you want. You don't actually want to move it, because if you move it, we won't be able to find it in our file. It will actually prompt you to say some users will lose access to this file. And so that's really important when you're working with a shared document, because everybody else will lose access to it if you do that.
Yeah.
So, but that's pretty much it for the night, isn't it, Helen?
That's all from us. So if you do have any other questions, or you did want one of us to come and visit your school, or you want to borrow something from our lending library, our details are on this slide here. So that's mine and Meridith's email and Twitter account. So just send us an email or direct DM us on Twitter or tweet us, and we can help you guys out. So thank you.
Thank you very much. We'll see you again soon. If you're at EduTech, keep an eye out for us next week. We're both at EduTech, and I've got a roundtable on building capacity